All right, let's talk about evidence. What does it really mean to have direct proof of something? I mean, we all think we know the answer, right? Seeing is believing. But what if I told you that the most direct, fundamental proof that science relies on is something that none of us can ever actually see?
So let's just start right there, with that huge question. When you and I say direct evidence, we mean seeing something with our own two eyes, right? Undeniable. But here's the twist, and it's what this whole explainer is about. Scientifically speaking, that kind of pure, unfiltered proof is kind of an illusion. We can't ever really get it. So, here's our roadmap for figuring this out. First, we're going to tackle that whole idea of direct evidence. Then, we'll see exactly where our own senses hit a wall, and that's going to lead us to two very different types of logic we use to make sense of things. From there, we'll actually go beyond simple proof before tying it all together with this really cool concept called authentic empiricism. Okay, let's begin our quest. First things first, we have to completely redefine what we even mean when we say we're looking for proof.
Now, this is a fascinating way to look at it. The source material argues that, 100% truly direct proof would be the thing itself. But think about that for a second. You can't observe a chair as proof if there's no separation between you and the chair. Observation, by its very nature, requires a little distance. So direct evidence can't be the thing itself. It has to be the closest possible observation we can get.
This little hierarchy makes it super clear. At the very top, you've got the thing itself. That's pure, unvarnished reality. Since we can't just merge with it to know it's there, we have to settle for the next best thing, the closest evidence. And in the world of science, the absolute closest you can get to anything is what's called a collision. A particle hitting a sensor, a force being measured. Literally every piece of scientific data you've ever heard about starts with that one simple interaction.
And this is where we run smack into the limits of our own senses. We just said that a collision is the gold standard for evidence. But here's the million-dollar question. Can any of us actually see a collision happen? And the answer is a huge, resounding no. Not at all. I mean, think about it. Can you see an electron striking a circuit board? Can you hear a single photon of light hitting a camera sensor? Of course not. Both that closest evidence and the collision itself are concepts. They're totally unobservable by our raw human senses. We only know they happen because of the effects they leave behind.
So, how do we bridge that gap? How do we know these things are real? Well, we see them only when they're represented by something else, like a blip on a screen or a number in a spreadsheet. And as the source material points out, to make that jump from the blip on the screen to the unseen collision, well, that requires a tool that isn't your eyes or your ears. It requires logic.
And this right here brings us to a super important distinction, because if we're going to rely on logic to understand what's real, we've got to be specific. It turns out there are two fundamentally different ways our brains draw conclusions. So on one hand, you've got probabilistic logic. This is the language of science. It's saying, hey, based on the last billion times we checked, it's highly probable the sun will rise tomorrow. But it's never 100% certain. It's a conclusion based on evidence, and evidence can always change. But on the other hand, you have absolute logic. This isn't about probability at all. A statement like all bachelors are unmarried men isn't something you prove with experiments. It's a necessary truth. We realize it through reason. It simply cannot be any other way. This leads us to a pretty big puzzle. If all of our senses and all of our scientific experiments are stuck in this world of probabilities, how do we ever get to be certain about these absolute truths? I love this quote because it really gets to the heart of it. We're so used to thinking that if you can't prove it in a lab, it's just, an opinion or an abstract idea. But the argument here is that absolute truth isn't abstract at all. It's real. It's just a different kind of real, one that you can't measure with a ruler or a beaker. So how do we build that bridge? Well, we don't throw out the evidence, we start with it. Step one is to observe. We see a triangle. We can measure its angles, and hey, they add up to 180 degrees. That's empirical data. Step two is to analyze. We think about the logic of what a triangle even is, a three-sided shape on a flat surface. And then step three is to realize. From that simple logical structure, we realize the absolute truth that the angles of any triangle like that must always add up to 180 degrees. See what happened? We went from one specific observation to a universal, necessary truth. And that three-step process, observe, analyze, realize, brings us to our final big idea. The source calls this whole powerful framework
authentic empiricism, and it's a great way of tying everything we've talked about together.
So, what is authentic empiricism, really? It's a way of thinking that respects both worlds. It starts with real-world, observable evidence, what we can see and measure. But it doesn't stop there. It insists that we have to then use our reason, our logic, to analyze the deep structures inside that evidence. And when we do that, we can access these absolute truths that observation alone could never, ever show us. It's all about seeing the world with both our eyes and our minds.
And look, if there is just one thing you take away from all this, let it be this right here. Empiricism, gathering evidence, is absolutely essential. It's critical. But it's the starting line, not the finish line. It's the raw material our minds use to uncover much deeper, certain, and absolute truths about reality.
So I'll just leave you with this to chew on. If our own minds have the power to grasp truths that even our best scientific instruments can't see, what else might we know for sure, just waiting for us to realize it? Thanks for digging into this with me.